Let's draw the production process for a pharma value stream. We'll open up the pharma application, and then we're going to use the sketch version to just draw the flow. We'll start with production time. The green shapes represent the inline flow. We'll use those. Here's the seed train components at the front end, and then the inline components for the upstream fermentation, and then perhaps the result goes into a whole tank. And now we can do the inline components for the downstream extraction. And perhaps there's an inline QA process at the end of that. And then transport to finished goods inventory. And then the customer shape to indicate customer demand. You can right-click the seed train shape to choose the appropriate visual. Now let's use the blue shapes to model some of the offline activities. This could be an add tank, the media that goes into it, and the kit needed to make the media. We'll just vertically align these under the operation they support. Here's media for the D2 activity. If the same media is used in two locations, we can use this media shadow shape and give the medias the same ID. Also, there could be general offline activities that we can model. We'll do a couple of these. Let's say a couple of general washing activities. We'll call them W1 and W2. Once we've sketched the flow, we can add the data shapes to the icons. The default data shapes for QuickPharma relate to lead time, and that's what we'll calculate first. Let's add in some of the processing time values, and then we'll go ahead and plot the lead time chart. We're ignoring the process resource and other resource values for now. We'll come to that later after we tackle capacity. We can also add a lead time summary center to the map. And then let's go ahead and calculate the blue values by doing a solve. We first need to create sequence arrows. This shows the material flow and will help us calculate the lead time. Once the solve completes, we can use the results to plot a lead time chart. And we can position the chart and scale it if we wish once we're done. Next, let's take a look at resource and capacity. We'll move the timeline down a little bit to give a shape for the capacity and resource add-ons. And then starting with the add-on for the seed train. We can model the resource for the seed train either at a single shape like the end shape, or we could model it at each step, however we wish. So it's a per period resource. For the upstream area, we could bundle together the various turnaround steps like CIP, SIP, etc. into a single variable called turnaround time. It's our option. We can then copy that add-on onto the other centers by using add-ons by example. Let's choose the more detailed add-ons for pre, post, etc. when we look at the downstream steps. Again, we can put the add-ons on one of the steps and then use the add-ons by example command to duplicate those on the other downstream steps. And now the add-on for the QA. And the transport. This gives us the equipment-based capacity variables. We could then solve the map to look at equipment-based capacity, and based on that, look at line capacity. And we'll add a capacity summary box that will be filled out by solve. So we can see the maximum utilization, and based on that, we can calculate the line capacity. We could also plot a utilization chart to look at utilizations of all the activities. Let's look at resource calculation aspects of the map. We'll add a resource summary table and then add some basic input parameters. What's the operational time per staff? This would be after breaks, etc. And then what's the staff attendance percentage? This would be holidays, absenteeism, etc. So this would give us the effective operational time per staff member. Now let's suppose we want to pool the resource and understand it for the upstream and downstream aspects. So let's call this upstream. And we'll connect that to the upstream activities in a second, and we'll call the other one downstream. The connection to the activities that the resource serves is made via pipes, and we use the auto pipe command. So I'm going to guess at the numbers of people needed to begin with, and we'll kind of do a couple of what ifs to modify the model. We'll add some additional data into each of the resource pools that talks about how many staff are in each pool. And then based on that, it'll give us an idea of resource utilization once we solve. So we can see we're heavily overutilized on the upstream side and a little less so on the downstream side. So let's increase the number of staff and then split them up between upstream and downstream again. So let's say 20 downstream this time and 10 upstream. Now the utilization numbers do take into account the operational time per staff and also the effect of that staff availability rate based on holidays, absenteeism, etc. We've also unhidden the resource required parameter so we can see how much resource is required for each of the activities. And solving one more time because we made that staffing change. And we can see the new utilizations, both in each of those resource pools and then overall for the facility. Let's explore some of the other add-ons on the map and see how they behave. Currently on the map, the total lead time is 17.6 hours. So let's look at our first add-on variable, which is the in-process hold. If I add an in-process hold value, it comes in with a hold time and a hold resource. So let's make this both 1 and 1. The in-process hold time actually contributes to the lead time. So when I solve, we would expect that lead time to go up from 17.6 to 18.6 hours. Let's confirm that. And as we expected. So the in-process hold time contributes to the overall lead time. Let's try some of the other variables. Another interesting one is the after post hold or after column hold time. This actually runs in parallel with CIP and SIP. So let's add it in here. Let's assume that it's 3 hours. Now, because it runs in parallel with CIP and SIP, those are currently 2 hours in combination. So this will add an extra hour to the overall equipment time. So the equipment time is currently 5 hours. This doesn't add to the lead time because it's done after the run leaves the station out there. But the equipment time currently is 5, and it should go up to 6 because the CIP, SIP, and the after post hold are in parallel. So we're comparing 2 to 3, so we're going to add an extra hour. Let's verify that. So there, the equipment time has gone up to 6. There's also a downtime add-on. So as you would expect, if we had downtime, the utilization would go up. So let's put a downtime of 5% on here. And we would expect this utilization number to go up accordingly. Let's confirm. So there, the utilization has gone up. There's also a stations add-on. So if I had multiple stations on the activity, then of course the utilization number should go down. So what if I had 2 stations here as opposed to 1? So we would expect our utilization number to go down by half, so about 45. Let's confirm. Yeah, as we expected. And then there's a couple of values here that are visual but don't take part in any calculation. So one of those is write first time, and then another one is yield. So these are for visual purposes, but as I said, don't take part in any calculations today. Another one that does take part in calculations is the activity time. So when I put the activity time in, if I don't have that add-on on there, then each station is assumed to run for the planned production time, which is defined here. So it's really 24 hours a day, 3 days. So it's about 168 hours per week. So we could reduce that. So instead of 168, let's suppose that this only runs 110 hours a week. So this should drive up the utilization number. Yeah, as we expected. Finally, there are also additional calculations available with these offline shapes. So for example, let's say for media, we actually wanted to talk about the processing time and the media resource and have that impact the resource calculations. So if we go find the media shape, here's the media details. And we can specify. So let's say every time the media is made, enough is made for a couple of runs, or 4 runs, let's say. And then it takes 4 hours to make it. It takes 6 hours of resource. And then there's a turnaround associated time with that. We'll say 3 hours, 3 hours of turnaround resource, and a transfer time from the media. So 1, and let's say it's 0.5. So you can add detailed data also for the media center, the tank center, the kit center, etc., if you want to model that on this map. And then the resource that gets calculated in here will get accumulated into our overall resource summary here. If you don't want to add that level of detail on the map, you could instead choose to hyperlink it. You could hyperlink the shape to perhaps the standard work or some document that has that detail, perhaps even a detailed value stream map of that arena. And there's a hyperlink shape to make that easier. So you glue that on, and then you use the insert hyperlink command. And you can specify, you can browse for the page name or the file name where the details exist. So you've got either option. If you want to label specific equipment, there's a label there as well. So for example, if we wanted to label these equipments up here, we could put a label and name them. So for example, this could be T246, T234, etc. It doesn't take part in any calculation. It's just really a visual scheme for us. Finally, there is a way to make the map a little bit more visual if there are classic equipment types that these stations are using that are easily recognizable. So in EVSM now, there's a process industry stack of shapes. So you can drag out a shape like that, and you can take off the framing, scale it a little bit perhaps, and even use a fill color. So you could annotate the map. Let's say that happened to be the kind of station here. You could annotate the map if that made it a little bit easier to read. And there's a library of some common shapes out there. So let's say, for example, this shape here was just a tank. Let's finish with a quick summary of what we've done and what we've seen so far. We started by creating the map, just the flow, using the sketch version of the stencil. Recall that the green shapes were those that were inline and contributed to the lead time. The blue shapes were offline, and this map shows the green shapes inline here, and the blue shapes for media, tank, kit, and offline resource like washing. Then we first calculated the lead time values. We exposed the data for the shapes, primarily lead time. We filled it in, so data was things like processing time, the time for the seed train, time for quality check, etc. And that calculated an overall lead time for us. We could also plot a lead time chart at the bottom. Then we added additional add-ons using the yellow shapes in the stencil. These are the ones that follow each of the green centers. And we chose what level of detail we wanted and actually which of the add-ons applied. So on the upstream side, many of the add-ons were not applicable, but we chose to consolidate a lot of the work after processing into total turnaround time. On the downstream side, we were more specific, and we had pre-add-ons, post, CIP, SIP, and in one case, we even had a post hold time, so after the post operation that ran in parallel with CIP and SIP, and we looked at the calculations for all of that. We also looked at some other interesting add-ons tied to the activity stations. So if you had multiple stations running in parallel, you could just add activity stations and change the number. We talked about a couple of the add-ons that were there for visual purposes but did not affect the calculations today, like activity RFT or write first time and step yield. And we could limit how much of the production time an activity runs by using this activity time add-on. So it could run a fraction of the planned production time. And then we also had one of the OE factors, downtime, where if you had an unstable machine, you could apply that factor and see the loss involved. So based on adding those capacity factors, we were able to calculate the total capacity. And based on the bottleneck process, we were able to see the line capacity. Now this is only based on equipment, and we could visualize that capacity using a utilization chart here. If we wanted to look at staff resource and its impact, we had an overall staff resource center that took into account the operational time per staff and also the staff attendance percentage. If we wanted to have a breakdown other than the overall map, we could create resource pools. So this resource pool would take in the resource requirements from the activity that it was piped into. So we created two resource pools, in this case for upstream and downstream. We could also have created resource pools that dealt with some of the offline activities, as in blue out here. So hopefully this gives a simple way to create a pharma value stream map with icons that are easy to understand. Most of the variables are predefined and standardized. all the calculations are automated and the visuals are automated.